An autoregressive distributed lag model contains lag terms of both the independent and the dependent variables, just like what we shown on this slide, the first equation. It is quite commonly used because of its flexibility. If you have an empirical problem, usually you want the data to speak for themselves. At least you want, and in the first step, you want to try to see whether those lag terms should be included and to what extent. So you may start with an ARDL model and check which one or what combination of those lags can give you the best result. So this is one of those commonly adopted approach in time series analysis. So for example, we have this ARDL11 model, which means we only include lag terms for the dependent and independent variable up to lag 1. You may have ARDL10 model, which means we have the lag terms of the dependent variable only. And we have the current term of the independent variables in the regression model. Note that in some of those textbooks, the authors will show you that an ARDL PQ model can be transformed into an AR model only. Okay, the DL model is infinite distributed lag model only, just like this one. So the AR part can be transformed into the DL part, as shown in this way. So those two type of models are connected. And for the interest of time, we are not going to venture any further along that direction. Just want to draw attention that this is commonly sort of a commonly discussed topic in time series analysis textbooks. Okay, let's come back to our ARDL model. And I think the key is how can we find out the optimal value for P and Q? Once we find, okay, that's the best value for P and Q, that's the optimal lag length for both the dependent and the independent variable, then we can proceed to estimate the model and interpret the result. So that's a crucial step to find the best model. We have some rule of thumbs or guidelines to choose P and Q. So first of all, if the P and Qs are correctly chosen, the serial correlation should be removed from the error term. So once you estimate the model, always look at the error term, perform an LM test, and check whether it still has an autocorrelation problem. If it disappears, that basically means at least the choice of P and Q are correct. Second one, you need to check whether the signs and the magnitudes of the estimate consistent with our expectations from economic theory. So if you have, it doesn't have to be economic theory, by the way, because the examples that we are using here are from economics. And the time series analysis is very commonly used in economics analysis. That's why I mentioned theory. If you are from social science research area and you have some theory, give you some expectation about the signs and the magnitudes of the coefficient estimate, the result should be consistent with your expectation. If they are different, you really need to come up with a good explanation. The third criteria is whether the estimates are significant, different from zero, which means they are statistically significant in the test. That means those are lag terms. Generally speaking, we prefer to have all variables to be significant in our model. If there are any insignificant ones, remove them and rerun the model. The last criteria is to use AIC and SC. Sometimes they call it BIC, that's the same thing. SC or BIC, that's the same thing. Those are mechanical, more mechanical compared with the first three, okay? And they do not necessarily give you the most economically meaningful model. So you still need to use your own judgment, look at the first three, then the fourth one can come into the picture. So let's use some example to demonstrate how to use those criteria, particularly the last one. Okay, so we have this Phillips curves example, and we are estimating an ARDL10 model to start with. So here we have the lag term of the dependent variable inflation rate only in a regression model. So we estimate this ARDL model, and we check whether the residuals are free of autocorrelation problem. So that's the correlogram of residuals. And we can also see that, okay, here is the LM test for autocorrelation. So correlogram look at correlation coefficients one step at a time. So it's always bivariate. It may not be able to capture higher order autocorrelation issue. On our right-hand side on the slide, that's LM test that is capable of capturing higher order autocorrelation. So you may notice that up to lag 5, your correlation coefficient is significant at 5% level, which means there is a higher order autocorrelation issue in the residual series, at least at the 5% level. At the 1% level, it doesn't exist. So we further investigate this question by extending the lag terms up to 6 for P and up to 1 for Q. And the software can give us the AIC and SC statistics for us to make a decision. Those values are all in relative terms. So you pick the ones that are the smallest, because they are all negative. So we find the ones with the largest absolute value, and we find that ARDL40 model is the best one in terms of AIC and SC. So the regression model can be estimated in this way. We only include 4 lagged terms of the dependent variable in our regression model. And you may notice that the effect of past inflation rate is distributed among 4 periods. So T-1, T-2, T-3, and T-4. So that's the relationship that we estimated by using this ARDL model. And we let the data speak for themselves. And of course, once we estimate this model, you always need to check whether the correlation coefficients are, the coefficient estimates are consistent with the theory. In this case, that makes sense to us. And we also need to check whether the error terms are free of autocorrelation issue. Okay, so those criteria are all met. So this is the estimation result. We also have another example. That's the Occam's law. And we start off with a ARDL02 model. So this is the case where we have lagged terms of the independent variables only. We also have this ARDL11 model. So you have the lag terms of both the dependent variable and independent variable. So we check the lag term up to 2 for P and up to 3 for Q. The output from the software are given over here, and we find that the ARDL11 model is the best based on both AIC and SC. So sometimes it is not uncommon for AIC and SC disagree, which means if you look at AIC, you may choose model 1, and if you look at SC, you may choose model 2. If that happens, people usually choose the one, usually use based on make decision based on SC, because SC usually give us the most parsimony or the simplest model.